You have already learnt that there are over 115 elements. Have you imagined that how they usually exist? We saw that several elements like oxygen, nitrogen, and hydrogen exist as diatomic molecules. Today, we are going to find out their bonding. Let's start. My name is Shushmita. Learning outcomes. At the end of this session, you will be able to understand about Electronic Theory of Valence by Lewis and Kossel. Ionic and covalent bonds. Formation of ionic compound. Formation of covalent compound. Keywords are noble gases, octet rule, chemical bond, ionic bond, covalent bond, cation and anion. Before starting this session, let's look at this concept map. Electronic Theory of Valence by Lewis and Kossel. There were a number of attempts to explain the chemical bond formation between atoms in terms of electrons. But a satisfactory explanation for this concept was given by Kossel and Lewis in 1916. They gave this concept independently. The basis for their theory was valence in terms of electrons. They provided logical explanation of valence on the basis of the lack of chemical activity of noble gases, which led to the proposal of octet rule. Octet rule. It may be stated as the atoms of elements tend to undergo chemical changes that help to leave their atoms with 8 outer shell electrons. If you observe the practical behavior of atoms of main group elements, when they are allowed to undergo chemical changes, they try to get octet electronic configuration in the outer shells. Let us understand this with the following illustrations. Group 1A elements try to lose one valence shell electron from their atoms to form corresponding unipositive ions, which get octet in their outer shells. But group 2A elements leave 2 valence electrons from their atoms for same reason. And similarly, group 3A elements form corresponding tripositive ions. Now, if we found out for group 6A elements They try to gain 2 electrons into the valence shells of their atoms during the chemical changes and form corresponding di-negative anions, which get octet in their outer shells. Group 7a elements form corresponding unianions. Group 8a elements, the noble gases, do not try to lose or gain electrons. Ionic and covalent bonds. Causal proposed the ionic bond electrostatic bond based on the following facts. Ionic bond is formed between atoms of two dissimilar elements like highly reactive alkali metals 1A and highly reactive non-metals halogens 7A. Due to transfer of electrons from the atom of one element to the other. Noble gases except helium have 8 electrons in the valence shells of their atoms. They are chemically inactive and stable. The positive ions cations and negative ions anions that are formed due to the transfer of electrons from the metal atoms to the non-metal. Atoms experience the electrostatic forces and get attracted to form chemical bond. As this bond is between charged particle known as ions, it is called ionic bond. Sometimes based on the forces being electrostatic, the bond is also called the electrostatic bond. As this valence concept has been explained in terms of electrons, it is also called the electrovalent bond. Sodium chloride is formed from the element sodium and chlorine. It can be explained as follows. When sodium Na atom loses one electron to get octet electron configuration, it forms a cation Na+. Chlorine gains the electron from Na atom to form anion. Transfer of electrons between Na and Cl atoms results in the formation of Na plus and Cl minus ions. These oppositely charged ions get attracted towards each other due to electrostatic forces and form the compound sodium chloride NaCl. Let us explain this with sodium chloride as our example. In sodium chloride crystal, each Na plus is surrounded by 6 Cl minus and each Cl minus by 6 Na plus ions. Ionic compounds in the crystalline state consist of orderly arranged cations and anions held together by electrostatic forces of attractions in 3 dimensions. The crystal structure of sodium chloride is given below. NaCl is said to possess face-centered cubic lattice crystal structure. The number of ions of opposite charge that surround a given ion of given charge is known as coordination number of that given ion. Generally, elements of metals tend to lose electrons to attain the octet in their valence shell. This property is called as the metallic character or electropositivity. Similarly, nonmetals like oxygen, fluorine and chlorine acquire electron configuration of elements of inert gases by gaining electrons. This property is called the nonmetallic character or electronegativity of the element. An ionic bond is formed between atoms of elements with electronegativity difference equal to or greater than 1.9. The tendency of losing electrons to form cations or gaining electron to form anions depends on atomic size, ionization potential, electron affinity and electronegativity. The atoms of elements with low ionization energy, low electron affinity, high atomic size and low electronegativity form cations and vice versa. G. N. Lewis, 1916, proposed that atoms of some elements could achieve an octet in their valence shells without transfer of electrons between them. They can attain octet configuration in their valence shells by sharing the valence electrons with one or more atoms. The electron shared between two atoms belong to both the atoms, and the sharing of electrons between them leads to the formation of a chemical bond known as covalent bond. The electronic configuration of an atom is 2,5, and to have octet in the valence shell, it requires 3 more electrons bonding. When two nitrogen atoms approach each other, each atom contributes 3 electrons for bonding. There are 6 electrons shared between two nitrogen atoms in the form of 3 pairs. Therefore, there is a triple bond between two nitrogen atoms in N2. Bond length or bond distance is the equilibrium distance between the nuclei of two atoms which form a covalent bond. Bond energy or bond dissociation energy is the energy needed to break a covalent bond between two atoms of a diatomic covalent compound in its gaseous state. When a covalent bond is formed between any two atoms, irrespective of the nature of the atoms, the bond length and bond energies are expected to be the same. But practically, it was observed that bond length and bond energies are not same when the atoms that form the bond are different. The theory could not explain the bond angle of many compounds. That is, it fails to explain the shapes of the molecules. what you have learned today? Ions are positively or negatively charged particles formed by the loss or gain of electrons respectively. The force between any two atoms or a group of atoms that results in the formation of stable entity is called chemical bond. The outermost shell of an atom is called valence shell and electrons in the shell are called valence electrons. The gases belonging to O group are called noble gases because they are reluctant to combine with other atoms. Except helium, all other noble gases have an octet of electron configuration in their valence shells.